All right, my name is Chuck Gardner. I'm a subject matter expert for NYSERC, and I put together this after-school or rainy day project for some BoeBots, using some out-of-the-package BoeBots, 2 BoeBots, and just a couple of extra pieces. In this case, I had about a 20-foot length phone cord with four conductors and one MEMSIC accelerometer chip. It's available on Parallax website. Part number is 28017. It's come standard in the NYSERC Cyber Physics kit. Using just 2 BoeBots, accelerometer, and phone cord, we're able to have a BoeBot that'll control the other with the tether, kind of like an old school throwback tethered remote control car, except here when you tilt the controller BoeBot, the BoeBot that's rolling does the same thing. So it's kind of cool. The video, about 25 minutes long, is going to have a schematic followed by an example of the wiring diagram, analysis of the code that I wrote. You're certainly more than welcome to customize it, followed by a short video demo. If you have any questions, you can email me at chuck.gardner@cyberinnovationcenter.org or link to us through nyserc.org. Thanks. All right, let's take a look at the schematic layout for the accelerometer driver. This is lucidchart.com. I use this for my schematics and flowcharts. This is the Parallax MEMSIC accelerometer, 6 pins, and we're going to set this up right now. So I have a couple icons down here for my input-output pins, my VDD and VSS. And to start, I'm going to need VDD, so we're going to take a copy of this. Put it way up here, and VDD connects to pin 6. So if you use Lucidchart and you get lines that go through your drawings up here, there's a tool, Edit Line Type. It defaults to curved lines. I like the squared off lines. It tends to keep them out of the way, and I can bunch them up. If you'll see in a little bit when we've got multiple lines going to ground, or for example, this works really well. So for this setup, we also need pins 9 and 10. Those are going to take the X and the Y values. And these are going to be inputs. So I'm going to want my input symbols for 9 and 10. All right. We're going to need outputs for 0, 1, and 2. That's going to be what's sending the signal across to the other BoeBot. So we'll put them there. This is the gap represented by the cord, the phone cord going to the other BoeBot. So the other BoeBot's going to be here. And it's going to need 1, 2, and 3, but it's going to need, 0, 1, and 2, but it's going to need 0, 1, and 2 as inputs. So let's put them in almost the same spot. Slide that down a little bit. And our centering lines tell us we're good to go. Both BoeBots need a ground, so we're going to copy this VSS. One here. Put it down there-ish. One over here. All right. Now we've got our components and we're ready to start wiring. So we've already got VDD into pin 6. Pins 3 and 4 of the accelerometer go to ground. So we can make that connection right now. And I'm going to drag this down a little bit so it doesn't get in the way of pin 0. Pins 2 and 5 contain our X and Y signals. Pin 5 contains the X, pin 2 contains the Y. And I want my Y signal through a 220 resistor to pin 9. So I need to grab a resistor down at the bottom of this screen. It's off of my video area here, but down at the bottom of the screen there's more shapes, and you can actually pull in electrical symbols, HVAC symbols. I was working on some stuff before. So here's a resistor. I need a resistor. Ooh, it's just too big. I'm going to need a resistor here. That's going to be a 220. I'll fix that in just a second. Let me slide everything here over. There we go. So now we can put this 220 right there and pin 9. I need another one. Control Shift D for Mac. Sorry, Command Shift D, duplicate. All right, I've got my 2 resistors, and I want pin 9 to take the X. So I'm going to come around here to 5. And I'm going to drag this line down. Bugger. All right. Let's slide this. No, let's slide this up. Can I do this? Oh, you're going to be a pain in my butt. Okay. You guys down. Bring you down. Pin 10 is to Y, and VDD goes to 6. And for the purpose of this build, 1 doesn't get used. 1 is the T signal, but we're not using that for this build here. So there's our MEMSIC accelerometer wired to VDD, pin 9, pin 10, and ground. Let me just get this up. There we go. Okay. Ugly but effective. Okay. So pin 0, 1, and 2 are sending our signal to our other BoeBot, and that's just a straight swap. Straight swap from one pin to the next. That's a good idea. Okay. From one pin to the next. And again. And the last connection we had was ground to ground. And that's it. That's the schematic for connecting the MEMSIC accelerometer from one BoeBot to the other. Like we said, the MEMSIC is entirely contained within the driver BoeBot, along with the 9 and 10 pin receiving the signal through the resistor from pins 2 and 5 on the accelerometer. 3 and 4 are connected to ground. The grounds are jumped from BoeBot to BoeBot. And then 4 wires going across. I had a 4-wire phone cord. Again, you can use a network cable, anything with more than 4 or more conductors. This would have been the driver BoeBot, and there's nothing to happen here except processing of the 3 incoming signals. All right. All right. We're going to take a look at the wiring diagram for the MEMSIC accelerometer controlled BoeBot. So we've got our driver on the bottom, our roller on top. This one is going to be on the floor. This one is in your hand. This is a program called Inkscape. It's on my Mac. I use this for making wiring diagrams. My crude attempt at a BoeBot breadboard. This is an even cruder attempt at the MEMSIC accelerometer. You can put it anywhere up and down the breadboard you want, just as long as it's in this orientation. You've got 3 pins on the left, 3 pins on the right, and they have to jump the valley, if you will. This is going to need 2 220 ohm resistors, so I've got them in place already. This BoeBot here is a breeze, so that's going to be the one we'll do last. We'll start with the bottom one here first. Oh, goodness. There we go. Okay. So 6 pins on the accelerometer, 1, 2, 3, 4, 5, and 6. The way this goes here is 6 goes to VDD, 3 and 4 go to ground, 5 contains our X, and 2 contains our Y. So we're going to send 2 into pin 10 via this 220, and we're going to send X into pin 9 via this 220. These 2 are going to go to ground, and then this one's going to go to VDD. And of course we've got the 4-wire harness to bring in here too at some point. Alright, so off screen I have my library of parts, wires and stuff that I've used in other builds that we'll just bring in and adjust to fit. So first thing I want to do is let's take these 2 to ground. So I'll need a black wire. Let's shorten this up and start right off the bat into ground. I'm going to shorten this handle up a little bit. Okay. Okay, now we need to also take this one to ground, and I'm just going to use a jumper around the accelerometer like that. Okay, so pins 3 and 4 are now connected to VSS. Let's connect pin 6 to VDD. I'll need a red wire. Doesn't have to be red, I enjoy going with convention. And that's going to go right here to the first pin. Drag the handle around so we can see it. And ooh, shorten this one up a little bit too. Okay, so we've got pin 6 going to VDD. The only thing left is to get these 2 into their respective pins via the resistors. Let's start with the resistor. I'm going to connect this, oops. Raise. There we go. One more time. Get it above the text. There we go. Let's start with this one into pin 9. And then we'll copy it almost into pin 10. Okay. The other end, oh my goodness. Object, raise to top. Okay. Let's get another one real quick. Put him right there. Alright, so this is going to be the Y, which is pin 2. Oh, sorry about that. There we go. So I'm just going to take this directly to pin 2. No need for a jumper wire. All right. This one's going to go to the X. Which is around the back. We'll go up and over. Look at that. No jumper wire. All right, and that's all the accelerometer needs, is 2 resistors and 3 jumper wires to make the connections. Resistor should be plenty long enough to make that connection. Oh, to make that connection, come on now. Keep coming. There we go. The resistor wire should be plenty long enough to make that leap over the top of the accelerometer. All right. And the way I've got the program worked is that the signals that I'm sending to the other BoeBot are going to come out of pins 0, 1, and 2. The phone wire that I'm using is 4 conductors, so I can send 3 signals plus ground. And I'm going to send the ground from here. Sorry about that. I'm going to send the ground from this pin right here because it's a nice short reach between these 2 groups. So let's bring in our jumper wires. Here's my black. green, yellow, and red. All right, sticking with convention, we're going to send black to ground. And I'm going to send red to pin 2, doesn't matter. We are going to get that out and away from the accelerometer. I'm going to send green to pin 1, doesn't matter. It just matters when you get to the other BoeBot, of course. And yellow, to pin 0. Oh. As I said, yellow to pin 0. All right. All right, and that's it. That's it for this BoeBot. It's now wired as the remote controller. 2 resistors, MEMSIC, and fork conductor going across through the BoeBot. Like I said, the other BoeBot is a piece of cake. I'm just going to bring black into ground, and I'll use, rather than busting out any jumper wires, we'll use the header up here to gain ground. And then I'm going to follow the same pattern I did before. So red, green, yellow, 2, 1, 0. Red, green, yellow. Red. Whoopsie daisy. Red, green, and yellow. Let's see what it looks like. You get the point. I can clean these up and bring these, what have I done? Delete. I can, bring these out so they don't interfere with our picture. Housekeeping. And that's it. That's it. All right, that's the, ooh, that's ugly over there. There's the wiring diagram for our accelerometer controlled BoeBot. All right, this is the code for the accelerometer tethered remote control BoeBot. This is the Parallax IDE environment. It's the Google Chrome extension. This is on the Mac, but of course it'd look the same if you were on PC. This code's a little big, a little involved. I'm going to explain it now, and I'll have a version copy and pasted to the comments so that you can use it for your programming. I like to make the programs make sense, so I use pretty expletive variable names. Interesting here, these are all bits, it's just ones and zeros. The accelerometer requires word size variables for the x and the y values, so that's why we've got them there. So I test if the accelerometer is in neutral, if it's rolling forward, back, tilting left, tilting right, and then if it's got a forward right tilt or a forward left tilt. And those are the 7 conditions. 1, 2, 3, 4, 5, yeah, 7 conditions we're testing for. All right, so there's 2 subroutines here. And you see it's just a do loop, and what I've got here is you've got 2 BoeBots. You've got the BoeBot that's rolling and the BoeBot that's in your hand. Get nav commands is the one that is the roller. He's the one that's on the floor. So right now if I ran this code, it would be destined for the BoeBot that's going on the ground. To get the code ready for the other BoeBot, put a comment there and delete that one, and now I'm ready to send nav commands. And this is the code I'm going to load up for the driver. And that's the main code. Everything else is subroutines. So send nav commands, we'll go over that first. That's the one that's in your hand. So to run the accelerometer, you need 2 pins. The X is going to go into pin 9, the Y is going to go into pin 10. The command is pulse in, 9, 1, our variable. Remember, that's the word that's going to store the values of inclination. 10 is going to store the Y values. If you want to execute this line, it'll put a debug up and you can actually see what the values are, and you can verify the ones that I have later, which we'll talk about. So after we excite the accelerometer and get our values back, we run this subroutine called getNavVariables. So we'll go take a look at that right now. Here's getNavVariables. And this is where the values of the accelerometer come into play. Typically, an accelerometer on an assembled BoeBot, that means all 3 wheels on a level surface, is reading 2500 in the X and 2500 on the Y. So with that, I have a value of 24, which is going to trigger anything out of neutral below, and in 26 is going to trigger anything out of neutral above in both the X and the Y. I've got the same numbers. So if X goes below 2400, it's going to trigger it being tilted. And the X direction of tilt, in the way that I have the accelerometer installed, if I tilt it to the left, the X is going to go down. If I tilt the BoeBot to the right, the X is going to go up. If I tilt the BoeBot nose down or pitch it forward, the Y is going to go up. And if we tilt the BoeBot backwards or nose up, the Y is going to go down. So that's where these values come from, and that's where these common sense variable values are going to turn on. So if X is between 24 and 26 and Y is between 24 and 26, we can assume the BoeBot's neutral. So I'm going to turn neutral on. If it doesn't fit those conditions, I'm going to turn neutral off. If X is greater than 26, this means we're pitching to the right. And Y is still within 24 and 26. That means it's not tilting forwards or backwards, just to the right. We turn right on, otherwise we turn right off. If X goes below 2400, Y stays the same, we tilt left. And then we start analyzing the Ys. As Y increases, it's pitching forward. So as Y tilts forward and X's remain the same, then we turn off or on or off tilt forward. If Y decreases, then I tilt back. I don't have enough wires to send a back left and a back right signal, so I'm just tilting back. And then my forward is obviously if it's pitching forward. If it's pitching forward and tilting to the right, I go forward right. If it's pitching forward and tilting to the left, I go forward left. And that's the extent of the getNavVariables subroutines. So after we getNavVariables, then we analyze the values. And basically, I just want to check if these are on. Otherwise, they're off and I don't do anything. So if tilt forward is on, and what I've done here is turn this into a little binary spreadsheet. So I've analyzed the pins. We're sending out signals 0 on 0, 1, and 2 on pins 0, 1, and 2. So if I want to send out a binary 0, that's going to be 0, 0, 0, low, low, low. And I'm going to do that when I have tilt forward. So when tilt forward goes on, I'm going to send out a binary 0. We're going to need to receive a binary 0 in the getNav commands. This is the other BoeBot. But if I want to receive a forward, I'm going to receive a binary 0, 0, 0. So this is a pretty neat encoding method to use only 3 cables to send as many signals as possible. So figure if I have 3 lights and I want to count in binary as far as I can, I have the option of all lights off. The first place light on, that would be a high, a low, a low. This is a binary 1. I can go low in the 0 position, a high in the 1 position, and a low in a 2 position. This would be a binary 2. I can go high 0, high 1, and a low 2. This would be a binary 3. I've run out of low digits, so I need to go to my 3rd column. So I go high on 2, low on 1, low on 0. This is a binary 4. And I've got a binary 5. There's a high, low, high. Binary 6, obviously, would be low, high, high. And then binary 7 is a high, 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 all on. If I wanted to count to binary 8, I would need 4 digits, or 4 cables, or 4 lights. I only have 3 in my phone cable, plus 1 to carry the ground. So I can only count to binary 7. Since I only had 1 more value left over, I didn't feel it was necessary to do any other back drills, like back left or back right. So we're sending these commands based on binary values 0 through 7. So all I did was I listed these. I said, okay, I'll call forward 0, back 1, right 2, left 3, forward right 4, forward left 5, and neutral 7. Listed them out, programmed the table right here. Did the same thing for the receiving side. So let me back up. This is the extent of the driver. So remember our send nav commands. This is our driver. Send nav commands activates the accelerometer, gets the values, assimilates the variables. Now we analyze the variables and send that signal with these highs and the lows through the cable, through the tether to the other BoeBot. We return and loop and it's ended. All right. So let's look what happens with the roller. This is the BoeBot on the floor. So get nav commands is the roller subroutine. Get nav variable, here's get nav commands. And that's it. It's just these 7 lines. 1, 2, 3, 4, 5, 6, 7. And it's the same table, just in reverse. Now I'm listening through pins 0, 1, and 2. I'm listening for a 0, 0, 0, which is a binary 0, and that's going to be my forward subroutine. If I hear a binary 1, or if pin 0 is high, pin 2 and pin 3, 1 and 2 are low, that's a binary 1. Then I'm going to go backwards. Binary 2 through 7, remember there's no 6. And there's the table for binaries 0 through 7, no 6. 0, 0, 0, 1, 0, 0, 0, 1, 0, 1, 1, 0, 0, 0, 1, 1, 0, 1, and 1, 1, 1. And that's it. Hope it helped. So this is the accelerometer tethered BoeBot. This is the driver. This is the one you're going to have in your hands, tilting to control the motion of the roller. Again, the wiring on the roller is fairly straightforward. The tether just comes straight into pins 0, 1, 2, and ground. On the driver, I've got pins 0, 1, 2, and ground, and then the accelerometer going into pins 9 and 10 on the X and the Y. Alright. So what's happening now is this is registering that this is in neutral. Essentially, it's on solid, it's on level ground, and the wheels aren't turning. Alright. As I tilt this BoeBot's going to roll. So I can tilt forward, I can tilt backwards. I can tilt to the right, to the left. I can even go forward and to the right. Can't do that with back though. So there's only 3 wires, and we'll talk about why I can only send so many different combinations of signals down the line to generate neutral, forward, left, right, forward, left, forward, right. I can only send those 5 plus this one. 1, 2, 3, and back. 7 signals is all I can send. Uh-oh. Okay.